In this video, we are going to see the creation of Azure Service Bus namespace in portal, and then we'll try to send and receive your message using the created resource with the help of C# programming and SDK libraries. Before even diving into the demo part, we need to understand the couple of core concepts called queues and topic with respect to Azure Service Bus. Because Azure Service Bus uses these two core concepts to handle the event. So we need to be well aware of these two concepts even before creating a resource in Azure Service Portal. So what is queue? Queue is used for one-to-one communication. So it allows only one consumer application to receive a message and process it. Once the message is processed by receiver application, that will be removed from queue. Queue uses pull mode to deliver a message, which means only on requesting new data, the message will be delivered. Messages in the queue is ordered and time-stamped on arrival. With respect to queue, the message will be sent to the queue and queue will stores them until the receiver application is available to receive and process them. Once the message is received in the queue, that will be durable until its delivery. For that, we'll be having redundant storage or spreading across the availability zones that we'll understand when we configure or create a resource in Azure Service Portal. Topic is used for one-to-many communication. So it allows more than one consumer application to receive and process the message. Topic is used for publish subscriber scenarios, meaning there could be more than one sender application called publisher and more than one receiver application called subscribers. Topic can have multiple independent subscription and each can listen for a subset of data that exactly what they are interested on. Each of the subscriber will receive a copy of message based on the configuration. Otherwise, topic also will work exactly same like a queue in terms of other properties. Now we'll move to Azure portal and start creating service bus. Inside Azure portal, we can start searching using service bus and we'll be getting a suggestion service bus. Inside this resource, we can create our service bus. When we try to create a service bus, it will ask us to create something called namespace. In Azure Service Bus, namespace is a container for all messaging component, including queues and topic. Inside this namespace only, we can create n number of queues and topics. So this namespace is a kind of application container for all the messaging component for Service Bus. Now we'll start filling the details. Inside subscription, we'll be choosing our active subscription. For resource group, I'll be creating a dedicated resource group called service bus demo and namespace name. So this namespace name should be unique across global. So it should be unique not only within our subscription, across the subscription it should be unique. And I'll be giving like service bus demo 0001. Yes, it is acceptable. Now we need to choose the pricing tier. There are three different types of pricing tier are allowed for this service bus. One is basic and standard and premium. Each are having different supporting features. For basics, we do have only queue supported. It doesn't have any support for topics. Whereas in standard, it support both queue and topic. Both of this pricing tier has maximum messaging size of 256 kilobyte only, and both of these pricing tier is using shared capacity, meaning the resource what is used for this service bus will be shared across all the resources. There is no dedicated resource. The premium pricing tier comes with dedicated and isolated resource allocated. Hence, we can guarantee on stable performance and availability. Also, it has a maximum message size of 100 MB and it does have support for both queue as well as topics. This premium pricing tier comes with fixed pricing. That is because the resources are dedicatedly allocated for our service bus alone and that will not be used by any of the other resources. And we do have the list of different feature for supported for each pricing tier in Microsoft documentation. I'll be attaching this link in the description of this video. For this particular demo, I'm going with standard pricing tier because I might need both queues as well as topic. I'll be selecting the standard one. That's it for this window. We'll be moving to the next window, which is as advanced. Here we have couple of options. One is the TLS version and another one is local authentication. This particular TLS version will be used during the communication between client application and service bus. The communication between client application and service bus will be encrypted using this particular TLS version. So we are going with the highest one, which is default. And the next one is local authentication. Azure Service Bus has two ways to authenticate the resource. One is using Microsoft Entra ID, that is formerly known as Active Directory, and other one is shared access signature, shortly known as SAS keys or connection strings. If we if we disable this local authentication, the SAS flow will get disabled. So we cannot get the SAS keys or connection string from this. So it can be authenticated only using Microsoft Entra ID. Now we are going with the enabled one because throughout this series I'll be using SAS key flow only with the help of connection strings to connect the client application and service bus. That's it. Inside networking, we have a couple of options whether we want the service bus to be exposed to the public network or private. We want to consume the service bus from outside of the Azure cloud, so we'll be enabling it as public. That's it. We'll be reviewing. It might take couple of minutes to validate the. Now the validation is passed. We'll start create. This might take a few minutes to create it. Yes. Now the resource is ready. We'll go to the resource, and here is what the thing. So under the namespace, what we have created, we have the queues and topics available to use. Now we'll start creating our first queue under our service bus namespace. So we'll go ahead and click the queue. We'll give unique name for our queue. Next property is maximum queue size. This is the disk capacity of our queue, that how much messages can be persisted within our queue. This can vary from 1 GB to 5 GB, and based on our pricing tier what we have chosen, this will vary. We can choose this size based on our need. The next property is maximum delivery count. This is the number of attempt that service bus will do in case of failure of sending message. If one message is failed to send or failed to be consumed by consumer application, then Azure Service Bus will try to resend the message for this much number of time. After this much number of attempt, the particular message is considered for dead lettering queue. Oh, maybe we may have some other consumer application listening for the dead letter queue will get notified, and that will be processed by that particular consumer application. But after reaching this much number of attempt, the particular message will be removed from main queue and it will be moved to dead letter queue. The next property is message time to live. This is the expiry time, or we can say it as a lifetime of the message within a queue. After this particular time, that message will be considered as a expired one, and that will be moved to dead letter queue. Within this time period, if the message is not consumed by any consumer application, then that will be considered as an expired one. Then the next property is lock duration. From our previous section, we learned that queues support one-to-one communication. So with the help of this lock, peak lock, or we'll call it as a queue lock, Azure Service Bus queue achieving the one-to-one communication. Immediately after sending a message to particular consumer, the Azure Service Bus will acquire a lock for the particular message, so that the particular message will not be sent for any other consumer application. That will mark it as a already in progress one. After this particular period of time, if the consumer application who is processing that particular message, if did not acknowledge, and if the message processing is not completed within this duration, then the message will be enabled for another consumer application to process it. If the first consumer application who is already processing that try to complete that, it cannot complete, it will throw an exception because the duration is already expired. Then the next property is enable auto delete on ideal queue. If we enable this particular option, they if the queue is ideal for this particular duration, then that will be deleted, that will be marked for deletion. If the queue did not receive any message for this particular duration, then that will be auto deleted. The next option is enable duplicate detection. If we enable this option, again we need to configure the duration. So within this duration, Azure Service Bus will trace all the history, message history of this queue to identify the duplicate message. So we can guarantee that within this duration, the message is delivered only once. There is no duplicate message will be delivered if we enable this with a particular time duration. And the next option is enable decluttering on message expiration. Yeah, we have already seen that we will be configuring our time to live for a message after this particular time of expiring. If we enable this option, the particular message will be moved to the decluttering queue. And we can enable partition to increase the throughput. If we enable partition, our queue will be scattered around different brokers and data stores, which will increase the throughput. And the next one is enabling session. We have already seen that we can achieve ordering of message delivery in Azure Service Bus. That is with the help of these sessions only. You can see the Service Bus sessions allow ordered handling of outbound sequence of related messages. If we enable this session, so the order of message delivery will be guaranteed. And the last option is forward message to queue or topic. If we enable this option, the message that are coming to this particular queue can be forwarded to some other queue or topic. Right now we have only one queue configured in our namespace, so we are not getting anything. So we'll try to do all these, we'll try to explore all these options in our programming demo. Right now we are not going to enable anything, we are just going to create a simple queue without any of this, with the default option. Yes, now the queue is ready. You can see the properties whatever we have assigned in the configuration section is displayed here. We can review and we can change whatever we want. Now we'll go to the Service Bus Explorer to just explore our queue. As we just created a queue newly, it doesn't have any message. You can see there is zero message in our queue. We can just start sending and receiving a message within Azure portal itself. But right now we are going to use .NET Console application to connect the service bus using connection string, and that will send and receive a message using C# programming. To connect the service bus from any external application, we need a connection string. As we discussed earlier, the service bus and client application can connect using either Azure Entra ID or using connection string. For this particular demo, we are going to use Azure SAS key. So that is nothing but shared access policies that can be created inside shared access policies. This shared access policy can be created inside a particular queue level or inside namespace level also. You can see the shared access policies available inside namespace level as well as inside particular queue level also. If we create it in namespace level, the all the components are under this namespace will have the access. And if we create under the particular queue, it will have only a limited access for the particular resource. Right now I'm going to create inside the queue the connection string. Now we'll go here, and I wanted to create a connection string for both sender application and receiver application separately. I'm going to name it as a sender with send privilege alone, and going to create it as a receiver with just listen permission alone. Yeah, both are now created. Now I have already created a couple of console application to send and create a message. Now we'll go ahead and start writing our code. For that, we need a .NET SDK to start connecting Azure Service Bus, known as Azure .messaging Service Bus. This I have already installed it. I'll just try to refresh, showing hold on. Okay, I'm just installing it now. Granting permission. Now we need to create service bus client, new service bus client. You can see this expect the connection string. This is what we just created. You can see this connection string is having entity path as q1, so this connection string is valid only for the particular queue. If we have any other queue inside the same namespace, this connection string won't work. So from this connection string, we'll create a sender dot create sender. The sender will accept a queue name or a topic name. Right now we are going to connect a queue and our queue name is q1. Now our sender is ready. Now we need a message. What is the message? We are going to create new service bus message, and we are going to pass plain message as first message, and we're going to use the sender, right? Sender dot send messages in particular message. That's it. We're going to write console message is published, or we'll say pushed successfully because it's a queue, and we'll just make the application to wait. That's it. We're just creating the service bus client, and we are creating sender with the help of our queue name, and we are creating message whatever we want, and we are just sending. We'll try to run it. Yes, we got the message. Message is published. Now we'll go back to our queue, service bus explorer. Yes, you can see now we got one message published in our queue. Just try to see the message itself inside portal. I'll try to peek from start. So there is one message. It's a bit slow. Yeah, now we got the message whatever we have posted, and it has it will be having its own unique message id, and this is the zero delivery count because there is no receiver application, there is no attempt to send this message, there is no delivery count. That's it. Now we'll try to consume this particular message from our receiver application. Same package we're going to have. Stop this. Similarly, we'll create service bus client, new service bus client. This time we need to take the receiver connection string. Go to the shared access policies, go to the receiver, taking the connection string of receiver application. We'll use it. That's it. Now we'll create a receiver instance. Service bus client dot create receiver. Again, this will accept queue name or service name, topic name. Sorry. Now receiver is ready. Now we'll consume a message asynchronously, receive message asynchronously. creating a client and we are creating a receiver instance, and we are just reading the messages synchronously, and we are just logging. That's it. Just waiting for the connection. Yes, we have received a message, first message. Now the Azure Service Portal, and we'll try to refresh and peak to start. You can see the message still exists in the queue. You can see this message still exists in the queue. It is not removed because, but we already consumed the message, but it is not removed from the queue. That is because we did not take any action against that message. We just received and we just consoled. That's it. So we need to take some action against that message, like we can perform complete, or we can perform reject, or we can even defer, and we can transfer the message. So these kind of four different action we can take against the received message. So all these will be seeing in detail. All these different operation against this message we'll be seeing in our upcoming video. That's it for this video. Thank you for watching.